Alright, so you can get these forms on Cal Nevada website. There's handouts for apprentices for vectoring. If you look under vector file, I think you can find it somewhere. But anyhow, let's look at this. First thing I look at is KV. There's only one can. This is going to obviously be a single phase load. It's not going to be three phase because there's just one can. But I'm just going to keep it simple. So let's start with the easiest one. You only have one voltage here, but usually you would have two on the nameplate. But let's look at the primary. When you think primary, it's the first number, right? So when your primary voltage, look at the first number, 4800, 4800. There's no second number here, but if there is, just look at, well, for your primary, just look at the first one. So look at the first number and look at the first number on the nameplate. If they match, they are the same, right? So it's a delta. If they're the same, okay, it's always delta. That's how I remember it. Your second kind of reminds me of second number, right? So when your secondary voltage, just look at your second number, which is 240, right? And your second number, which is 240. If they are the same, they are delta. They are the same. If they were to be different, I ask myself, why? Why are they different? So I would see a Y in there, right? So if they're different, it would be a Y. But that's not the case here because they are the same. First number, primary, secondary, second number, they are the same. Okay, so secondary is going to be delta, primary is going to be delta. So anyhow, it's not going to be a delta per se because there's only one can. If in order for it to be an open delta, you need two cans, but here it's a single can. So let me draw this out for you. So on your deltas, you start at 0. I'm not going to use a ruler because I'm holding a phone. So on a delta, you'd start at 0 and you go connect it to this, right? And this is your A phase and your B phase. I would have drawn another line right here if it was an open delta, and if it was a three-phase bank, three-pot bank, then it would have been a closed, it would be like a triangle, right? So anyhow, so your outside is your primary, inside circles for your secondary. This corresponds to 0 degrees, this corresponds to 30 degrees, and so on and so forth. So your secondary side, oh, by the way, over here, draw a P and an S. So if they're the same, right, you would series the coils inside. If they are not the same, if your second number is not the same, then you'd have to parallel connect the coils inside. In order for you to parallel connect, right, it looks like this, right? So one coil, let's think of this as their left coil and this is your right coil. One coil would be A, B, C, D, right? So if you were to parallel connect it, it would be alley cat, bad dog, right? See how they're in parallel? But in this case, we connected in series. So you connect the cat and the bad together, or whatever you want to call it. So you just connect these together. Okay? Series. Circle the S. Okay? And then look for any special information down here, which there are none. So your secondary is going to be a delta. So you start at 0 and you go to 120. So this is your A phase, B phase, your transformer 1 here. And your arrow goes there because if this was a 3 phase, it would be going clockwise. So you'll see later on. And then secondary side, same thing, make an arrow. And it's the current is going from high to low. So it would be coming out of here and going into here. So X1 is higher, and then your X4 is where it's leaving, right? And the customer wants also 120 and 240. So eventually you're gonna have to ground this. If you don't ground this, the customer is only gonna get 240 because they're, from the air. Like when you have the secondary wires going to the customer. Okay, you'd have 3 wires. if you only had 2 wires, you could only provide them with 240, right? But if you were to ground this from here to here, would be 240, right? Because basically that's that voltage here. But if you go A to neutral or B to neutral, it's like saying this or this, it's going to be 120. So the customer has 3 wires and they're getting 120 and 240, right? So how would I, let's first draw this. So your this is your H1 bushing and H2 bushings. So it's always going from high to low, H1, H2. So when you look at transformer 1, label this 1, right? What's going into transformer 1? A phase is going into transformer 1, right? Because your arrow points towards that way. So your A phase is going into transformer 1, and what's coming out of transformer 1? B phase is coming out of transformer 1. That's how you hook it up. Vectoring helps you kind of learn how to hook it up too. So that's transformer 1. This is also transformer 1 secondary side, right? So X1 is where it's going in, right? Oh yeah, there's your A phase and B phase, right? Oh, I hooked this up wrong. I hooked it up wrong. It's going in that way, and it's coming out of B phase. See that? It's coming in. X1 is going in A, and it's leaving. B is leaving at X4, right? B is leaving X4. And then since we grounded this to provide them with 12240, this is in the middle, right? X3, X2. So X3 is equal to X2. Should be right here somewhere, right? In the middle somewhere. And I will draw a ground, and I will have to put secondary ground, SG. Okay, so this one here is complete, and I'll show you how to do the next example.